This lesson is the end of the topic. So on Friday, I'd suggest that you finish off any blanks or start writing a cheat sheet for your in-class practice next Wednesday. Quantiles. Methods kids from last year would have seen this briefly. Let me remind you what normal CDF does. Normal CDF does this. You have the lower, you have the upper. Normal CDF tells you how many percent is inside those two. So quantiles is the opposite of that. The opposite of this is what number does a certain percentage of the data lie below or above. We find that using inverse norm. So you can get your calculator out, please. Clear. How do I access inverse norm? You access in the same place as normal CDF. So you press second. You press vars again. Can you see number 3 in norm? Yep. So select that, please. Now, there's 2 older calculators in the room. My calculator on the board looks like yours. Okay? Okay, so there's some older ones as well. If you have the newer calculator and it says left, center, or right, can you default it to left? Just put it on left if you have a newer one. Okay? If you have an older calculator, so what I mean, I can actually demonstrate this. I need to teach it for both because there still exists some older calculators here. So if you have an older calculator, you're going to see that. Can you see the people with the older calculator? There's no left, center, or right. Just to start off with, if you have a newer calculator, leave it on left. Default it to left. Okay? I'm going to teach it for the older calculator to start off with, and then you'll notice you have notes about dealing with a newer one. Okay? So what does inverse norm expect? It expects 3 things. It wants area, it wants mean, and it wants standard deviation. I need to explain to you what the area is. The area is this colored in thing below a particular number. So what inverse normal is telling you is when you tell it the area, let's say 60%, inverse normal is going to tell you what number on the x-axis 60% of the data is below that. So it's like the opposite of normal CDF. If you've got an older calculator, you input those numbers as above. If you have a newer calculator, it asks for these like this. It asks you what the area is. And basically, after you enter the expected numbers, you press paste again or enter on the older calculator. The calculator tells you the number below which the entered area of the distribution lies. Show you're working out by telling me what you entered. Now, the newer calculator. If you have a newer calculator, you have that option. What do you reckon left means? It colors in to the left. What do you reckon right means? It colors in to the right. So you've got a little advantage here because you can change the direction of what's colored in. If your calculator can do this, please take advantage of it. Older calculators cannot set the direction. They always go to the left. So there's one particular question type they need to think a bit more. Okay? Let's do an example so you can see this. X is normally distributed with mean 23.6, standard deviation 3.1. We want to find a number where 95% of the data lies below it. So in my calculator, I want 95% of the data to lie below it. What's my area going to be? What's 95% as a decimal? So we'd go 0.95. And what does the question say? The mean was 23.6 and the standard deviation was 3.1. You guys with the newer calculators, keep it as left because we're pretending your calculator is the old one. The old one can only color in left. So if you go paste, enter, what does your working out look like? You would go inv, norm, bracket, 0.95, 23.6, 3.1, equals 28.70 to 2 decimal points. So you could say 95% of the data lies below 28.7. If you have an older calculator, you don't need to do any fancy business. Why? Because you're coloring in left in this question. We want what's below 95%. So the older calculator works like that. You'll see for B, I need to demonstrate both. Okay? So notice B, find the number for which the proportion is above K and 65%. So what is that saying? The number K where 65% of the data lies above it. I'm going to pretend I have an older calculator. I've got an older calculator and my calculator can only color in to the left. But this question is asking for the area to the right. So it's often helpful to draw a normal distribution and it's saying this, I want 65% of the data, 65% above it, and I want to work out what K is. My calculator can't color in to the right. But if you do some thinking, if I want 65% above it, what's the percentage that's below it? Good. Why do I need to do that? Because my calculator doesn't let me color in to the left. So your working out for this would be inv norm. Because I've got an older one, you'd go 0.35, comma 23.6, comma 3.1 equals. So second dist inv norm 0.35. It feels wrong because the question's asking for 65%. Why don't I put 65%? My calculator has a weakness. It can only color in to the left. The question wants it to the right. So I do some thinking and go, well, I want it 65 above. What percentage below is going to be the same as that? 35. Okay? So then I've chucked those in, paste it. So that's telling me K is going to be at 22.41 to 2dp. So what would you say? Therefore, 65% of data lies above 22.41. If you have a new calculator, this is what you can do. You have the advantage. You go inv, norm, you don't need to think about it. What percentage is the data asking for? 65? So you go 0.65. You'd put the mean in, 23.6. You'd put the standard deviation, 3.1. But you have the feature. Where's the tail going to be if I have a new calculator and I want to color in on the high end? Right or left? Right. So tell the person marking that you set the tail to the right. And hopefully with this new calculator, if I go second dist 0.65, but I set the tail to the right, I should get the same friggin' answer as what I demonstrated for the old calculator, which you can see. Okay? So 22.41, 2dp, same. Please, if you have a newer calculator, take advantage of that. Do not use the center mode. No one can work out what center means. Right? Those are not worded questions, so I just want to demo a worded question. Let's look at that bio class again. The percentage grades in a particular bio class have a mean 58, standard deviation of 13. What's the lowest percentage grade a student could have in the class and still be within the top 10% of students? Am I coloring into the right or am I coloring into the left? Think about it. Top 10% to the right. If, and like that discussion we were having, if you have trouble interpreting that, draw a picture. So we're talking about a bio class, their grades are spread like that. Where is the top 10% going to sit? Up here somewhere. That's 10%. And I'm trying to work out that grade. What is the grade that's the cutoff point for being top 10%? So inv norm, bracket. Let's do it for the new calculator to start off with because most of you have the new calc. What's the area going to be for 10%? 0.1. What's the mean for the class? 58. Standard deviation 13. I have a new calculator. So can I set the tail to the right? Mm-hmm. So I tell the reader that I've put it to the right. And what's that going to spit out? I don't know off the top of my head because I just made up that question. Inv norm 0.1, 58, 13, and it's set to the right already. Oh, I accidentally set it to the left. Go to paste. What the? Oh no, don't tell me it's ruined my video. So I can...
It was 0.0.
Did I type something wrong? Oh, that's why. It's freaking out. There's no area. 0.1, paste. Okay, that's telling me the cutoff point is 74.66 to 2DP percent grade to be in top 10% because it's a worded question. Old calculator. The old calculator, I can only work to the left. I can't colour in to the right. So what percentage do I care about? If 90. So the area is going to be 0.9, 58, 13. I can't change it to the right. So I'm just, even though this is the new calculator, I'm going to pretend to use the old one by setting it to left. 0.9 instead. Paste it. See, it's the same. Percent, same. So hopefully that covers both calculator types, old and new. I believe all of the school provider ones are the newer ones, but I'm just covering my ass here to make sure that everything's covered. That's the end of the timeline. 5C, just those. After that, have a break. I'll give you a cheat sheet paper on Friday.